the Sky This Month with your host, Dave McDonald.
Welcome to the Sky This Month. I'm your host, Dave McDonald, and this is October 2025. I hope that you got a chance to enjoy some of the features that we talked about last month in September. Aerospace Fest at the McAuliffe Shepard Discovery Center was outstanding. Well over 800 people in attendance, and it was a great time to meet the astronaut there as well. And what we're going to be doing today is we're going to talk about the sun, which you see behind me, because the sun recently has been very active, and you can see a bunch of sunspots. Those numbers that are there in white are assigned to the sunspots so they can talk about, they being astronomers and astrophysicists, can talk about sunspot number, whatever, because the sun experiences differential rotation at the equator. It rotates different speed from the northern and southern pole. But the thing is, after 26 days, when the equator comes around, maybe those sunspots are still there, or a group of them is there. So they can refer to a certain sunspot grouping by those numbers that are there in white. So the sun has been very active, and I thought it would be a good time to talk about the sun. But a reminder, if you're catching this right at the very beginning of the month, that Saturday night, October 4th, from 7 to 9, is International Observe the Moon Night at Bryant Field in Belmont, New Hampshire. And that's at 1050 Laconia Road, Belmont, New Hampshire, 03220. So hope that you get this in time to see that. But all kinds of neat things are going on in the night sky, which we'll talk about a little more towards the end of the show. But right now, I'd like to introduce to you two very special guests. And Tyler Flanagan, just welcome you.
Good to meet you. It's good to be back.
It's good to meet you too. And Tyler is going to be going to Manchester Community College in November to become a lineman. And then I want to welcome Reese Sachetta. Welcome aboard. And Reese is going to be working on his education at Laconia, or I should say Lakes Region Community College, and is going to be working his way into the computer field. And so they both are previously students at Belmont High School, and we're going to continue talking about the sun. And so I'm going to throw it over to Tyler and Reese to share some good, basic, and somewhat interesting, and with some depth to it, information about the sun. Okay, take it away, Tyler and Reese.
Thank you. So here we have the sun.
Can he not see it though?
A slideshow put together.
So the sun has many layers, just like the Earth does. It starts in the core, all the way in the middle. And the central region of the sun is the core. It's 20 to 25% of the sun's radius. The total radius of the sun being 430,000 miles around. It's about 27 million degrees Fahrenheit in there, 15 million degrees Celsius. So very hot. The pressure in the core is extremely high, and this is where the sun gets its energy from, as the energy released there powers the entire sun as hydrogen atoms fuse into helium in a process called nuclear fission, which we'll get into in later slides. The second layer of the sun is called the radiative zone, and it's between the core and the convection zone, and this extends about 25 to 70% of the sun's total radius. The energy from here moves outward via radiation. The radiative zone acts as the sun's slow energy highway, taking the energy from the core and then transferring it all the way to the corona, which is the outer layer. And that's the energy that we get from the sun. It's an extremely dense region, being between the core and the next layer, which we'll get into. so that makes it very dense with all the mass below it and above it. The temperature here is about 7 million Kelvin to 2 million Kelvin. 7 million Kelvin is about 12 million degrees Fahrenheit, so also very hot, but not quite as hot as the core.
The third zone will be called the convection zone. It's the outermost layer of the sun's interior, lying just between the radiative zone and the next, the photosphere. It extends about 2,000 kilometers below the surface of the sun, which would be called a photosphere. How it works, the energy moves outward through convection and currents instead of radiation. Hot plasma rises to the surface, cools, then sinks back down, creating convection loops. This process is similar to boiling a pot of water. The key features of the convection zone would be plasma movement creates the sun's granulation pattern seen on the photosphere, responsible for sunspots and solar magnetic activity through turbulent motion. This plays a role in transporting energy that ultimately radiates as sunlight. It's important because it drives solar phenomena such as solar flares and coronal mass injections. Importance of it drives solar phenomena such as solar flares and coronal mass injection, called CMEs. It helps regulate how the sun's energy reaches the core. It helps regulate how the sun's energy from the sun's core reaches space. Studying convection improves our understanding of stellar dynamics and space weather.
And space weather is one thing that is basically drives our weather, is what's going on with the sun. So the image that I showed you at the top of the show of this of the sun here with those white numbers around the sunspots actually was taken by an instrument on one of the satellites that is studying the sun. And this image was taken on October 1st. It seems fitting, where this is the sky this month for October, that we would start the show with an actual image of what the sun looked like on October 1st.
So the next layer of the sun is called the photosphere. This is the light of the sun that we can see from Earth. It's about 500 kilometers thick and a little bit cooler at around 5,500 degrees Celsius or 5,800 degrees Kelvin. As I said, this is most of the sunlight that we see here from Earth, and the bright of day. This is what comes from the photosphere. This is where you can see sunspots or granules, also solar flares, which we refer to as sun prominence, which will be the last slide. Sunspots are cooler, darker regions of the sun, and these are actually visible from a telescope with a certain filter if you have one. Don't just look through a telescope and look at the sun. You might see something for the last time.
Yeah.
But it's pretty cool. You can see them. I've seen them personally. They're pretty cool to see. It's a little different because the filter you use makes the sun orange and everything else black behind it. So really all you're seeing is an orange dot with some black spots on it. But that's the sun.
And then there's also what are called hydrogen alpha telescopes that you can look at the sun in what's called the hydrogen alpha region of the spectrum, and that allows you to be able to see more specifically, greater detail of the granules, and the sunspots have a more defined edge around them, the prominences going off the edges, and we're going to talk about CMEs in a little bit. So if you keep that in mind, particularly if you are interested in buying a telescope to look at the sun, hydrogen alpha is the way to go there.
And actually, to add more context, the sun you're seeing behind us here, that's about what it looked like through a telescope with a filter on it.
Yeah. Can we go back to that slide?
That right there.
No, the slide that you have right there.
Oh.
Yeah. Yeah. So when you're talking, see the average temperature, right? The middle bullet on the left side. So if you're into photography at all, you want to have the right light balance. And so the average temperature, 5,800 K or Kelvin, if you're going to buy film for a camera, like I know these days pretty much everything's digital, but there are still purists that are buying film. But in either case, there's a setting on your camera called ISO, which stands for International Standard Organization, and you'll set your camera to 5600 Kelvin. And if you're going to a store to buy film, if you're going to use light from the outside, the sun, you're outdoors taking pictures, you want 5600K film. And if you're indoors, it depends on what lighting you have, whether it's fluorescent or LEDs or what you're using. Each source of light has its own color temperature. And again, the color temperature for the sun is 5600 Kelvin. And I think that's a good thing to keep in mind. And check out on your phone. If you're using your cell phone to take images, see if you can find a setting for ISO. Because again, a lot of phones, cameras have an auto setting. You know, let's just click on auto and let the camera figure it all out.
I want to get that perfect picture.
But if you want that perfect picture, as Tyler was saying, then you learn how to set the art aperture. You learn how to set the exposure. You learn how to set the ISO, all those numbers, and learn how to change the focus of your camera and such. So you can really enhance a lot of photography. A friend of mine was just sharing his experience at the Deerfield Fair here in New Hampshire, which is in, of all places, Deerfield. And he had some pictures in his camera and decided he was going to enter a photography contest. And this guy, his name's Nolan, he is one who plays with the settings. You know, he's not an auto person. He wants to play with the settings and get just the right image. And it may take multiple images, 10 to 20 images with slightly different settings to get the picture that he would like to get. And so anyway, he entered 3 pictures or so into the photography contest at the Deerfield Fair, and he got first place.
Wow.
He got first place with an image he took a couple years ago with his cell phone. And the reason he got first place with his cell phone picture is he took the time to learn settings about the ISO, the exposure, and they're called f-stops, which is like the widening of the iris of the lens, how much light you let in. So all that to say, and this is just a quick little side note, a rabbit trail related to photography, but an important aspect of photography, spoiler alert, is lighting. And the sun is certainly a major source of light. So, sorry to interrupt, but I just found that little tidbit of 5600K interesting.
I can vouch for that, definitely. I took a college class on photography, and lighting is everything. Even the time of the day, where the sun's at,
Yes.
it can really affect a picture. It really can.
How much atmosphere the sun has to go through, how close to the horizon
Between
it is.
12 o'clock in the afternoon and 4 o'clock in the afternoon, it really can, it's a whole different type of shooting.
Yep. Cool.
So up next we have the chromosphere. This is a thin layer above the photosphere. It's about 2,000 to 3,000 kilometers thick. So they say thin, but it's really not that thin. The temperature rises from 4,000 Kelvin to about 25,000 Kelvin. And these are actually visible during solar eclipses. That little reddish ring you see right before the sun is completely enveloped by the moon, that is the chromosphere. I've also seen that. It's pretty cool to see. The chromosphere is actually visible from during a solar eclipse with the correct telescope. It's a little reddish ring that you see right before the moon completely envelops the sun. It's pretty cool to see. It's definitely worth taking a telescope out and taking the time to set it up and taking a cool picture, or even just seeing it.
And so on that note, because you're referring to eclipses happening,
Right.
and the next eclipse in New Hampshire,
67 years.
it's something like that.
Yeah.
It's May 1st, 2079.
Yeah.
So
I'll be alive.
if
hopefully.
you, well, thanks for that reference. And so if you want to see a solar eclipse sooner than 2079, look up online. There's typically 1, 2, or 3 solar eclipses somewhere in the world. And I know that next summer there's something going on in Iceland that I'm trying to see if I could be like a tour guide on a cruise boat to talk about the eclipse. And then the year after, things are going on in Tanzania and Egypt, and there are eclipses all the time. I think 2033 in the United States. In Alaska, there's a total solar eclipse. So you can look up these dates and where they are. The thing is about a solar eclipse as opposed to a lunar eclipse, when you have a lunar eclipse, it's a big area that sees the total lunar eclipse. Like the whole of the United States could experience a total lunar eclipse. Whereas a solar eclipse, the path of totality varies a little bit from like 140 to 180 miles wide, and that's not that wide. So that's why solar eclipses are very rare in any one place, but lunar eclipses are fairly common in any one place. So solar eclipses do reveal, as Tyler was talking about, the chromosphere of the sun. And the eclipse that we had here in New Hampshire back on April 8th, yeah, thank you, on April 8th was the opportunity to see that chromosphere, and it was so bright that it made the sky not as dark as typically it might be. I also went to the eclipse on August 21st, 2017 down in Kentucky. I was in Hopkinsville, Kentucky, and that eclipse created a darker environment just because the corona or the chromosphere didn't show as brightly. So if you have an opportunity, check out some eclipses of places where you're able to get to in the time that they happen, and enjoy it, because it definitely is a rare and wonderful sight. Okay, back to you.
So next we have the transition layer. What is the transition layer? It's a thin region on the sun's atmosphere located between the chromosphere and the corona. It's a varying thickness of 200 to 2,000 kilometers, which is a pretty big difference, but it varies all the time. It marks a rapid temperature increase from 2,000 kelvins in the chromosphere to over 1 million in the corona, which is a crazy difference. 1 million in reference is about 1.8 million degrees Fahrenheit. So it's a crazy temperature. Key characteristics: it's extremely thin but a highly dynamic layer. Temperature rise sharply due to magnetic heating mechanisms that are near the sun, and responsible for ionizing solar gases, which influence their solar wind formations, which solar winds are a pretty important thing in our solar system. Importance in solar physics: it plays a crucial role in energy transfer to the lower solar layers to the corona. It's a source of UV rays and extreme UV emissions observed in solar telescopes, which is a big thing here, because the UV rays come down directly, hit Earth, and cause many types of problems with the body, least to say skin cancer. And it helps scientists understand coronal heating problem. Why is the corona so much hotter than the sun's surface?
And that is a mystery that we still don't know the final answer to, because you would think the further away you got from the surface of the sun and going out into outer space, that the temperature would go down, but instead it just jacks right up.
All right, next we have the corona, which is the outermost layer of the sun, the one you can see with the visible eye, which would be here behind us. We got a chart here outlaying kind of everything with the corona and then the rest of the layers. It's visible during solar eclipses as a glowing halo around the sun. So what we just talked about, the very prominent glowing ring around the moon when it goes in front of it, is corona here. It's extremely hot, temperatures rating 1 to 3 Kelvin, 1 to 3 million Kelvin, which is anywhere from 1.8 to 6 million degrees Fahrenheit, which is insanely hot. Composed of highly ionized plasma. It's a very low density, which is much lower than the rest of the layers of the sun, just because it doesn't have everything pushing on it. It's just the raw space pushing on it. It contains magnetic loops and coronal holes that influence solar wind. Again, same thing with the last one we talked about, influencing solar wind, which is the two outermost layers. The source of solar wind, which affects Earth's magnetic sphere and space weather, which will, can really affect us in space travel and stuff like that. It's a coronal mass ejections, the CMEs, which we talked about previously here. They originate here and impact satellites and power grids, things all over the world. It's responsible for the X-rays and the UV emissions studied by solar telescopes. X-rays having much more energetic and shorter UV wavelengths at a higher frequency, and then UV rays obviously come down and to the Earth's surface and cause many different types of problems here. I mean, not visible in the naked eye.
But as you mentioned, not visible to the naked eye. At the same time, it's the UV rays that affect your eye and can make you go blind or lose your sight.
Exactly. It's kind of like a silent killer there.
Yeah, exactly.
So next we have the nuclear fusion formula. What is the nuclear fusion formula? It's a light nuclei combined to heavier nucleuses that release huge energy. They power stars, including the sun. It's how a star is powered, pretty much. How they shine bright in the sky. The fusion formula is 2 hydrogen plus 3. Actually, can I cut that out? Can you just what is the next thing here? 2 hydrogen and what?
What do you mean?
Like in the formula.
Oh, 2 hydrogen plus 3 hydrogen.
Oh, this is hydrogen. Okay. All right. I'll start from.
And
So
helium.
Is that helium?
Yes.
Yeah. Okay. Yeah. All right. So the general fusion formula is 2 hydrogen plus 3 hydrogen into 4 helium plus 1 neutrino plus 17.6 mega electronic volts. Key points is the most efficient reaction for clean energy. Energy source from mass defect. Einstein's equal m2 squared, mc2 squared. The potential future power for the source on Earth, which nuclear fusion and nuclear energy is used in a few different countries across the Earth, but definitely not a widespread use of it.
So we have sun prominence here. As you can see, they're very large. That is one sun prominence, just a random one, and it's much larger than Earth, unfathomably larger than Earth. Obviously, the Earth's not that close to the sun, but they're huge, bright arches of plasma that extend past the corona of the sun, so the outer layer there. They can last for days, weeks, even months due to the magnetic field of the sun holding them in. And when they erupt, they become a CME, which we talked about. And it's a massive explosion of plasma that can impact Earth and the technology. So we refer to these as like a solar flare. And they can, shut down AI, or not AI, but technology and interrupt signals coming from satellites to Earth. They can be pretty impactful on our Earth. They're much cooler than the corona, being in space at about 5,000 degrees Kelvin. And they can be seen with a telescope as well. So if you have a good enough powerful telescope, you will definitely be able to see a sun prominence. And I haven't seen one yet, but from what I hear, they're pretty interesting to see.
And if I could interrupt and just bring back to something I said earlier, if you can get your eyeball in a hydrogen alpha telescope, prominences are very prominent.
It's in the name.
Yeah.
And lastly, we have CME. We've talked about it so much. So here it is. It's explosive release of plasma charged particles and magnetic field from the sun's outermost sphere, the corona, which we just talked about. The plasma consists of electrons, protons, and ions bound to solar magnetic fields. CMEs can inject billions of tons of solar material into space and travel up to speeds from 250 kilometers per second to over 3 thousand, which is 7 million miles per hour. How do CMEs happen? They're triggered by magnetic reconnection, sudden reorganization of twisted solar magnetic field lines, often associated with solar flares or sunspot activity, which we just mentioned. And they're more common during the sun's 11-year solar cycle peak at their solar maximum. And again, they have huge effects on Earth. Geomagnetic storms, the CMEs compress Earth's magnetic field, causing disturbances in the magnetic sphere. Technology disruptions can damage satellites, disable GPS, interrupt radio signals, and overload power grids, which is especially dangerous with hiking. The satellite phones can be not wiped out by this, but it can interrupt them, and in a time of need that would be devastating. Space hazards, dangerous radiation exposure for astronauts and high altitude flights. And then lastly, auroras, the charged particles excite atmospheric gases, producing colorful northern and southern lights, things we've seen recently here in northern New Hampshire. And that should conclude us there with the slideshow.
Okay, well, fascinating, the sun the daughter's pretty fascinating too, but particularly the sun is the source of life, because without the sun, we don't have the energy rays to create photosynthesis, to grow trees and plants and bushes, which livestock, eat. So the sun's energy is critical for life on our planet. And plus, it's nice to feel warm and not overly cooked and such as well. So enjoy the sun, but enjoy it safely. Don't forget to wear your sunglasses to protect your eyes from those UV rays, and also never look directly at the sun. Use solar eclipse glasses. You don't have to wait for an eclipse to use the solar eclipse glasses. And then if you're using a telescope, be sure you have the appropriate solar filter on it. Well, Tyler, Reese, thank you very much for being part of the show.
Thank you for having us here.
Oh, you're very welcome.
It's always a good time.
And it is always a good time. So let's talk about some of the things that you can see from your backyard that you may find in the sky in the morning, in the evening. You know what? We have an opportunity to see Halley's Comet. I'm going to tell you about that, so stay tuned. Well, hope you enjoyed that chat with Tyler and Reese about the sun. Now, something that you probably know is all the stars out there, they're suns. And each one of them has the same basic process, a nuclear fusion going on in it. And the larger stars fuse past helium. But right now, I want to bring you to October 10th. And right here you see the moon. And can you make out what the moon is next to or cutting in front of? It's the Pleiades in the constellation of Taurus the Bull. This is Aldebaran, the orange star that is the eye of the bull. And you can kind of see the face. It's kind of like that V shape. That sideways V shape is the head or the face of the bull. So this is only October 10th. So hopefully it'll be clear and you can catch out the beautiful sight of the moon passing by and in front of the Pleiades. Next, we have coming up is a great morning shot, and this is October 19th in the morning. And what you get to see on the morning of October 19th before sunrise, we're facing east in the direction that the sun will rise. We have a nice conjunction of the moon and the planet Venus. So that's going to be a great morning. If you can get up, face towards the east, and we're talking, this is about 6:20 a.m. on October 19th to be able to see the moon and Venus. And once again, the moon is on the move, so this is a one morning opportunity, October 19th. And then next is, I mentioned you have an opportunity to see Halley's Comet. Well, this is really early in the morning. This is like midnight on the 21st. And notice here that you have Orion's belt, and we're facing like southeast, so Orion has just risen, and there's a meteor shower going on a couple days before the 21st, a couple days after the 21st. But the thing about this, it's called the Orionids, and this is what we call the radiant point, where all the meteors seem to be radiating from. And when Earth goes through this dust trail of Halley's Comet, that is what produces the meteors. And the nice thing about that is it's going to be near a new moon, so the sky will be nice and dark. Tell your neighbors to turn off their porch lights and spotlights and such, and enjoy midnight, a little before, a little after midnight, the 21st of October, a couple days before, a couple days after, and you should be able to have a good show seeing meteors streak through the sky, and realize that those meteors that you see streaking through the sky were created by the dust particles left over from Halley's Comet. So there's some neat things for you to look at, and then a lot of people just enjoy seeing, well, when can I see Orion? Well, look southeast on October 21st and around midnight, and Orion is going to be coming up, and it will be rising sooner and sooner as the time goes on. So that's our show for October. I hope you enjoyed it. Hope you get a chance to get out, and don't forget to keep looking up.